Let's run it. Mike and Anasazi, AP Bio Enzyme Model. It is 12 in the morning and I want to go to bed, so we are going to get it done. Okay, so first concept is the anabolism of glucose. Um, it's a constructive process that takes in smaller units like amino acids and bonds them together to create bigger structures with an energy input like ATP. This process builds proteins, synthesizes complex carbohydrates, and constructs lipids and nucleic acids. Enzymes help as catalysts in these reactions. They speed up the reactions by bringing substrates together and lowering the activation energy for to make the bonding of molecules easier because it creates alternate, that is the word. The word's an alternate path for these. It's basically anabolism is just your dehydration synthesis because it brings smaller units and makes more complex units together. And then the opposite is the catabolism of glucose, or just catabolism. It's the process which breaks down more complex molecules into smaller and simpler ones to release energy like ATP. For example, in the digestive tract, the stomach, the more complex polysaccharides are broken down into smaller monosaccharides like glucose, which releases energy in the form of ATP so your cell can function. In this great model that Anasazi made, where is it? Dude, what the beans? Where is it? You could see the anabolism. Where is it? Anabolism of, this is catabolism. You can see the catabolism. I don't think it really matters. Catabolism of glucose. You see this? Broken apart, and it releases ATP. Wow. And then, dude, oh my god. Then for this part, the anabolism. See, look. This monosaccharide of glucose is coming together to make a larger polysaccharide. And then that's the wrong one. And then for this one, which I made, you can see that the catabolic reaction of glucose, the substrates go into the active site, and then they go in the active site, and then they break off, which detaches this bond that they have, this weakened bond, and that releases them in as monosaccharides, and then the process repeats again and again. Now we will be focusing on the enzyme substrate complex and activation energy. Activation energy is the initial energy input that it takes for a chemical reaction to start, and enzymes decrease the amount of activation energy needed for the reaction to start because they create an alternate path for the reaction to start because they lower the reaction rate. That really does not make sense. But Anasazi, she made a great diagram that I will be putting on the screen here when I edit this video to show what the activation energy with an enzyme is and the activation energy without an enzyme is. The activation energy without the enzyme is higher than the latter, okay? And then she has another diagram here that shows great what happens with the substrates right here. It's right here. It's definitely right here. With the substrates going into the enzyme's active sites. Okay, so enzymes are proteins. Some can be ATP that have active sites for the substrates to bond to. The substrate is the reactant molecule that bonds to the active site, and the active site is the surface of the enzyme that the substrate bonds to, catalyzing the chemical reaction. An allosteric site it's an inhibitor, so an inhibitor can go in there and that it can affect the shape of the active site, so the substrate can't go in and catalyze the reaction with the enzyme. Okay, now we are on to unusable versus usable energy. Unusable energy is the energy that is transformed and dispersed into a less concentrated form. It cannot be used for work again. For example, in like any chemical reaction or any reaction, matter of fact, um, heat is always released, like a bear running through. Usable energy is free energy that can be converted into useful work, like ATP. It's energy that is used for every reaction to keep a cell alive, to keep everything moving. Endergonic versus exergonic. An endergonic reaction is a reaction that needs energy to happen. It stores energy. It would not have a reaction without added energy. And then an exergonic reaction is one that releases energy when it happens. Energy is excluded from this reaction. So, like catabolism releases energy, so it would be exergonic, for example. And then I have a great sketch here that shows what is this one? The endergonic reaction energy required. So as you can see, the reactants are less than the products, and energy is required to create the products. And on the exergonic, you could see that the products release energy, or do the reactants release energy in, and then it produces the products. And this results in a negative amount. What is that called? Free energy. Is that free energy? I don't know what that is. The amount of energy released in the bar below. And then the amount of energy released, energy required for the endergonic reaction.